Okay, so we're going to take a look at our last example for this section, application problem. We're asked to determine the quadratic inequality that defines a solution region. So you can use a parabolic reflector to focus sound, light, or radio waves to a single point. A parabolic microphone has a parabolic reflector attached that directs incoming sounds to the microphone. So there's one over here in the picture. If you have a look at it, you can see that it has a parabolic shape. Okay, so this part here being the parabola right there. Rene, a journalist, is using a parabolic microphone as he covers the Francophone summer festivals of Vancouver. Describe the region that Rene can cover with his microphone if the reflector has a width of 50 centimeters and a maximum depth of 15 centimeters. Okay, so we're going to describe graphically what our parabolic microphone looks like. And we are going to let the origin, which is at 0, 0, represent the vertex. Okay, and we are going to let x represent the horizontal distance, in centimeters, because that's what we have here. Okay, and our horizontal distance is going to be the width of our reflector, right? So this really means the width. Okay, and we're going to let y represent the vertical distance, in centimeters, and that's really the depth of our microphone. Okay, so we are going to graph this. So we have a point at 0, 0. Okay, and that's the vertex of our parabolic microphone. Now we know that its depth is 15 centimeters, okay, and that's our vertical distance. So we know that we will go up to 15. And we know that the width of our reflector is 50 centimeters. Now because we have centered it at 0, 0, okay, and it's 50 centimeters across, that means that a point of interest in the negative region will be negative 25, and in the positive region will be positive 25. Okay, so if we draw in this parabolic microphone, and we want it to have a width of 50, this will be half of it. So half of it will be 25. So we're going to have a point at 25 and 15. And then the other half of our parabola will be in the left region, the negative region, up to 15. And so it will be at negative 25 and 15. And then we will draw in our microphone. Here we go. Okay. Now we could also position it like this. Okay, we could say that the vertex is at 0 and 15, and then we would have a grid that would look like this. Okay. And this will be 0. The depth of our parabola is 15, and the width is at 50. Okay. And halfway is 25. All right. Sorry, our vertex is not going to be at 0 and 15. It's going to be at 25 and 0. Okay, so what would that look like? Well, we're going to have a point at 0 and 15. We're going to have a point at 50 and 15, and we will have a vertex at 25 and 0. And we will get this. So you can see, you can position your parabola just about anywhere on the Cartesian system. Okay, and if you remember, this is very similar to your graphing project that I had you do. Okay, so we're going to describe our graph algebraically now. Okay, and if you take a look, we're gonna do this one. Okay, and if you take a look, we have a vertex at 0, 0, which means that the overall equation for this is going to be y is equal to ax squared. Okay, and that's because our vertex is at 0 and 0. Okay, and so we don't have, or sorry, our p-value and our q-value in our vertex form, which is this, is 0. So, you know, if p is 0 and if q is 0, we're just going to get y equals ax squared. Okay, so we're almost done. We pretty much have it. Okay, we know it's going to be in this form. All we really need to do is find out what a is. Okay, and there's a couple of ways you can do it. You can use your rise over run squared. Okay, so our rise being 15 and our run being 25. And so we get 15 over 625, and when we reduce that we get a is equal to 3 over 125. Okay, and a is positive because our parabola is opening up. The other way we can do this is to use a substitution point. And why don't we use 25 and 15, and we're going to substitute it into y equals ax squared. So y is 15, and x is 25, so that gives us 15 equals a times 625, divide by 625. And so a is equal to 15 over 625, where when we reduce it, we get 3 over 125. Okay, and so what is our equation? Okay, well, we're going to plug that into y equals ax squared, so y is equal to 3 over 125 x squared. That's our equation. All right, so let's graph it. We have 25 and 15, right? And then negative 25 and 15. And so we will graph it like this. Now, sound is picked up from space above the reflector. Okay, so if we want to write an inequality for this, okay, and the sound comes from above the reflector, that means that the region we're considering is this. Okay, when we go to write our inequality, well, above the line means greater than. Okay, and because we used a solid line to graph, that means equal to, so y is greater than or equal to 3 over 125 x squared. Okay, Now, the other thing that we will want to consider is a domain restriction. Okay, our parabola is only so wide. It actually goes from negative 25 to 25. Okay, so if you remember back last year when you wrote set notation for domain, you go x such that, and we want to go from negative 25 to 25. So we write negative 25 is less than and equal to x, which is less than and equal to 25, where x is an element of the set of real numbers. Okay? And so our final sentence. The region covered by the microphone can be described by y is greater than or equal to 3 over 125, where negative 25 is less than or equal to x, which is less than or equal to 25. Now we can also test our region here. Okay, so we can do a test point, and I'm going to pick, why don't I pick 0 and 10? Okay, so test. We're using y is greater than and equal to 3 over 125 x squared. And so y is 10, is greater than and equal to 3 over 125 times 0 squared. And so 10 is greater than or equal to 0. And is that true? Yes, it is. Okay, because 10 is greater than 0, and so we know that our shaded region is correct, and so our inequality is correct. And I think we've done everything, right? We've described the region that can be covered with his microphone. We have graphed it, written a domain restriction. Yes, we're done.